So how can we use the z-transform to better compare between two data sets? In this case, New Mexico and Texas. Well, we can actually use the z-transform to do direct comparisons. For example, we can ask the question, okay, the peak in New Mexico is 319. What would be the equivalent score in Texas, the equivalent number of new daily tests in Texas to match 319 in New Mexico, right? So if I want to know how many people in Texas would have to test positive to match relative that same number of tests, I can use the z-transform. Right? So we know that for New Mexico, the 319 new tests corresponded to a z-score of 3.5. Right? So now we're going to take the z-score, except we're going to flip it around. I'm going to take the z-score of 3.5, right? And I am going to multiply it by the standard deviation and add the mean for Texas, right? So we are undoing the z-transform, right? Rather than subtracting the mean and multiplying by the standard deviation, we're reversing it, and that gives us a score of 1,768.5. In other words, to get an equivalent increase in Texas of 319 in New Mexico, they would have to have a daily increase of 1,768 people, right? So these scores would be relatively the same, right? So this allows us to do those kinds of easy cross-distribution comparisons. So interesting enough, right, if we scroll down to the Texas data, you can see that at its peak of 1654 and a z-score of 3.2, right, Texas never actually had a peak number of cases that was equivalent to the spike we saw in New Mexico. In order to do that, it would need 1,768. In fact, if we come down here to the peak Texas had of 1654, we can see what 1654 would look like in New Mexico data. So we take 1654, we see it's a z-score of 3.2, right? So we take our z-score of 3.2, we multiply it by the standard deviation of New Mexico, right, which was 57, and then we add the mean of New Mexico, 116, and that would be equivalent to 298 new cases, right? So at its peak so far, Texas had the equivalent of 298 new cases in New Mexico. So this is a really solid way of allowing us to directly compare distributions. We can look at other questions. Say we wanted to decide that there's some sort of threshold that to us personally would mean that the number of cases are on the rise. So if we come over and look at our Z table, again, we could say that, I don't know, anything that is 10% or less likely to occur, I am going to attribute to an increase in number of cases. You may disagree with that. You may think it should be 5% or 2% or 1%. But I'm going to say 10% is going to be my threshold. Right? And if I look over here at that 10% on the appendix, and see that corresponds to a z-score of 1.28. So if I come back over into my spreadsheet, if I take that z-score of 1.28, and I want to see how many cases in New Mexico that would correspond to, again, we multiply the standard deviation in New Mexico, and then we add the mean of New Mexico. So that would be equivalent of 189 new cases. Well, what about in Texas? Well, again, the z-score 1.28 times the standard deviation in Texas of 387 plus the 414 mean would correspond to 909 new cases. So you can actually determine a percent cutoff in the table and calculate the number of scores or the number of new cases or whatever it is that you're looking at that would correspond to that cutoff. So the z-transform is actually incredibly useful. want to wrap this up, right, by digging a little bit deeper. So we've used mean, standard deviation, the z-transform to get a better understanding of this data, but there's more to being an intelligent consumer of information and data than just running the math. We have to think of the interpretation. Right? So has there been an increase in the number of infections? Well, if we look at New Mexico and Texas and those peaks, it sure seems like it. The chances of getting those peaks by chance alone are so small, something else has to be driving that, and the most likely thing that's driving that is an increase in the number of infections. But if we look at the data, we can see that New Mexico really had an isolated peak for a handful of days and went right back towards the mean, right, where our z-scores are fluctuating around 0 again. So it's a very narrow time period. Whereas in Texas, we have seen a pretty dramatic increase and consistent increase over multiple days without regressing back towards the mean. When we look at the histogram, we see a similar thing. That peak is really out here by itself, a single day. Whereas in Texas, the increase is clustering with multiple days. To me, it's more suggestive of an increase in number of infections in Texas because of that clustering. But we're still left with that one spike, which is clearly not due to chance. Something's driving it. Well, it could be an error in our data set or a clustering of testing, or there's all kinds of things that could be driving it, right? And the interpretation that it instantly has to mean an increase in infections is not necessarily the right hypothesis. And certainly when we look at the data, the fact that it's isolated, it makes it questionable. Interesting enough, when we actually break it down, it turns out what was driving this for New Mexico was a very unfortunate circumstance in the Otero prison, where it turned out that the coronavirus had infected the prison and there was 160 new cases in that prison. And that's what drove that. That one-day spike was attributed to the 160 new infections from that prison. But that prison has a minimal number of people in it, about 600 people in it, so it couldn't continue to drive the new number of infections. And once we kind of reached capacity of infection in the prison, we reverted back down towards the mean. So really, when you look at those headlines that say New Mexico has seen an increase in infection, it's kind of true, but it's being driven by this one solitary incident, whereas our neighbors like Texas and Arizona that show these cluster effects likely see a more legitimate increase in the number of infections. So hopefully this has shown you how we can use these descriptive statistics and transforms to begin to think about and intelligently process data. We will now, next week, take the next step into using this for actual hypothesis testing.